Welcome to the deep dive. Today, we're going to be stepping into the mind of Albert Einstein.
Ooh,
Not just the physics genius, but like the thinker.
right.
How did he approach problems? How did his thought processes lead to those incredible breakthroughs? We've got a fantastic YouTube documentary packed with stories and insights about Einstein's life and work to guide us.
Yeah, it's fascinating how we often think of genius as this innate, almost magical quality. But with Einstein, we can actually trace his thought processes.
Yeah.
We can learn from his approach and maybe even apply some of it to our own lives.
That's the goal.
Yeah,
By the end of this deep dive, you should not only grasp some key Einsteinian concepts, but get a taste of how he thought.
exactly.
Ready to think like Einstein.
Absolutely. Let's start with a core element of Einstein's thinking, visualization.
Okay.
Even as a child, he was captivated by things like a simple compass, trying to picture those invisible forces at work.
And this led him to his famous thought experiments later in life.
Yes.
Like imagine riding a beam of light.
Exactly. Einstein would visualize these scenarios to push the boundaries of what was considered possible. It's like a mental playground for physics.
Okay, I have to try this.
Yeah.
Imagine if you could shrink down to the size of an atom and travel through the circuits of your phone.
Oh, wow.
What would that be like? What would you see?
See, you're already on your way to thinking like Einstein. He used these thought experiments to explore the implications of his theories, often leading to breakthroughs.
Wow.
But it wasn't just about abstract physics. Einstein also found inspiration in everyday life.
Like that story about his happiest thought, right?
Yes.
He wasn't in a lab. He was just watching a man fall from a roof.
And instead of panicking, he had an epiphany. He realized the falling man felt weightless because he was following the curve of space, not being pulled by a force. This led to his revolutionary insight that gravity might be the curvature of space-time itself.
Okay, pause for a second.
Yeah.
Curved space-time. What does that even mean? For those of us who aren't physics whizzes.
Think of it like placing a bowling ball on a trampoline.
Okay.
The ball creates a dip, and if you roll a marble nearby, it'll curve around the bowling ball.
Okay.
That's essentially how gravity works, according to Einstein.
Okay.
Objects aren't being pulled by a mysterious force. They're following the curves in space-time created by massive objects.
So a falling man equals revolutionary physics.
Yes.
It makes you wonder what kind of physics your morning coffee could inspire.
Precisely. Einstein's genius lay in connecting these everyday observations to profound cosmic principles.
All right, think like Einstein moment.
Yeah.
How can you apply this to your own life?
Yeah.
What seemingly ordinary things in your day-to-day routine could hold the key to a new idea or solution? What if you looked at them with that Einsteinian curiosity?
This leads us to another crucial aspect of Einstein's thinking, challenging assumptions.
Okay.
He questioned even the most established truths, like Newton's law of gravity.
Wait, wasn't Newton's law considered like the law of gravity? Like set in stone?
Well, even Newton himself wasn't fully satisfied with it.
Yeah.
He knew objects are pushed, not pulled, but couldn't figure out what was doing the pushing.
So he left that as a mystery for someone like Einstein to crack centuries later.
Exactly. Einstein realized if gravity were a force, it should affect everything equally, including light. But if light were bending due to gravity, that meant space itself was curved.
Huh.
That was a radical departure from Newtonian physics.
So another think like Einstein moment.
Okay.
What's an assumption you hold in your work or life? Could challenging it lead to a breakthrough? Maybe there's a better way to do something, a different approach you haven't considered, because you've always done it a certain way.
That's the spirit. Einstein constantly questioned the status quo, leading him to challenge the very foundations of physics.
This guy was a rebel, even in the world of physics. It's inspiring, but it also makes you wonder,
Yeah.
did he ever hit roadblocks? I mean, he wasn't a superhuman idea machine, was he?
Of course not.
Okay.
Even Einstein faced setbacks and dead ends. In fact, he initially miscalculated the bending of light around the sun.
Oh no. What happened?
Yeah.
Did he realize his mistake?
He did, but not before some flawed eclipse expeditions tried to prove his initial incorrect calculations.
Oh.
It's a good thing they failed, or his theory might have been dismissed.
Wow, talk about a close call.
Yeah.
But it shows that even geniuses make mistakes, and that those mistakes can sometimes be stepping stones to even greater discoveries.
Absolutely.
Oh.
And it highlights the importance of perseverance, another hallmark of Einstein's thinking.
Right?
Even when things got tough, even when he faced setbacks or criticism, he never gave up on his pursuit of understanding the universe.
And that brings us to another fascinating chapter in Einstein's life,
Okay.
The race to complete the equations of general relativity with mathematician David Hilbert.
Oh, yeah.
Talk about high-stakes physics.
Hilbert was a brilliant mathematician, and when he heard Einstein lecture on general relativity, he thought, I can solve this maybe even better than Einstein.
Wow.
So you have these two intellectual giants, both striving to unlock the secrets of the universe?
It sounds like a cosmic game of chess with the universe as the board.
Yes.
So who won?
Well, it wasn't really about winning or losing.
Okay.
Their competition actually fueled their work. They exchanged letters, shared ideas, and pushed each other to their limits.
It's amazing how collaboration, even in the midst of competition, can lead to breakthroughs.
Absolutely.
What's fascinating is that even though they were rivals, there was a deep mutual respect between them.
Absolutely. After Einstein finally cracked the code and completed the equations, Hilbert acknowledged Einstein's genius.
Wow.
He said, every boy in the streets of Göttingen understands more about four-dimensional geometry than Einstein, yet despite that, Einstein did the work and not the mathematicians.
That's a testament to Einstein's unique way of thinking, his ability to blend intuitive leaps with rigorous mathematical analysis.
Yes.
He wasn't just a brilliant physicist, he was a true innovator.
Absolutely.
And it raises an interesting question for you. How can you use both collaboration and healthy competition to fuel innovation in your own field?
Yeah.
Think about the people you work with, your mentors, even your competitors.
Right.
How can you engage with them in a way that pushes you to think bigger and bolder?
That's a great point. It's not always about working in isolation. Sometimes the spark of competition, the exchange of ideas, can ignite those aha moments. Stay tuned as we delve deeper into Einstein's journey, exploring his struggles during World War I, his relentless pursuit of proving his theory, and the ultimate test that made him a legend.
Oh, this is going to be good.
Welcome back to our deep dive into the mind of Albert Einstein. Last time we talked about his unconventional path to genius, his mastery of visualization, his audacity to challenge assumptions, and even his setbacks along the way.
We even got a glimpse of that intense but ultimately collaborative race with mathematician David Hilbert to complete the equations of general relativity.
Right.
But proving a theory as radical as general relativity, well, that was no easy feat. It required a cosmic event of epic proportions. A total solar eclipse.
Because that's the only time you can actually see stars near the sun to see if their light is bending due to the sun's gravity, just as Einstein predicted.
Right.
And this is where the story takes a dramatic turn, intertwined with the outbreak of World War I.
It's incredible how world events, even war, become part of the scientific process.
Yeah.
Einstein was living in Berlin at the time, and suddenly international scientific collaborations were disrupted.
Right.
So how did he deal with this? Did he have any allies outside of Germany?
He did, and in the most unlikely of places, England. A young astronomer named Arthur Eddington became fascinated by Einstein's theory.
Hold on, England. Weren't they at war with Germany at the time?
Exactly.
Yeah.
It's a testament to the power of scientific curiosity that even amidst global conflict, there was a desire to test this revolutionary theory. Eddington saw it as a way to bridge the divide created by the war.
That's amazing. It's like science became a common ground, a way to connect across enemy lines. So Eddington was basically Team Einstein in the heart of enemy territory.
Yes.
What happened next?
Eddington knew the next total solar eclipse would be visible from Africa in 1919, so he set out on this daring expedition. He faced all sorts of challenges, treacherous travel, tropical storms, you name it.
It sounds like something out of an adventure movie. Was he able to get the photographs he needed?
It was a close call. On the day of the eclipse, clouds threatened to ruin everything. But just as the eclipse reached its peak, a break in the clouds appeared, and Eddington managed to capture those precious few images.
Talk about a nail-biting moment. What did the photographs reveal? Was Einstein proven right?
Well, analyzing those photographs was a painstaking process.
Yeah.
Remember, Einstein had predicted a tiny, almost imperceptible bending of starlight.
Right.
It was a measurement that pushed the limits of scientific precision.
I can imagine the anticipation, the weight of the world on Eddington's shoulders as he analyzed those images.
And remember, there was another astronomer in the picture, William Campbell, from California's Lick Observatory.
Right. He returned home empty-handed.
Yeah, he had tried to photograph the 1914 eclipse in Russia, but the war interfered, and his equipment was confiscated.
So was he involved in this 1919 eclipse as well?
Campbell was determined to get his own results, but his equipment was still stuck in Russia.
Oh.
He managed to cobble together some makeshift cameras and headed to Washington State, where the 1918 eclipse was visible. So you had these two astronomers on opposite sides of the world, both racing to prove or disprove Einstein's theory.
The scientific drama was unfolding on a global scale. It's like a scientific thriller. What were their findings?
Campbell's initial results from the 1918 eclipse actually seemed to contradict Einstein's predictions. He thought Einstein was wrong.
Oh no. So what happened? Did Eddington's results match Campbell's?
Not at all. Eddington's measurements, despite all the challenges he faced, seemed to confirm Einstein's theory.
Wait, so you have conflicting results.
Yes.
This is getting more and more intriguing. How did the scientific community react?
It was a divided verdict. The Royal Astronomical Society held a historic meeting in London where both Campbell and Eddington presented their findings.
Imagine being a fly on the wall in that room. The portrait of Isaac Newton himself loomed over the proceedings, as if reminding everyone of the monumental shift in scientific thinking that was at stake, whose results were ultimately accepted. Did Einstein's theory triumph?
Well, Eddington's findings, despite some initial skepticism, gained more traction. The announcement sent shockwaves through the scientific world and beyond. Because if Eddington was right, it meant that everything scientists thought they knew about gravity, about the very fabric of the universe, was fundamentally wrong.
And the news exploded in the press. Headlines around the world proclaimed Einstein's theory triumphs. Almost overnight, this obscure theoretical physicist became a global celebrity. It's like the world was ready for a new understanding of the cosmos, and Einstein provided it.
Yes.
But you mentioned skepticism. Did everyone embrace Einstein's theory?
Not at all. There were many who doubted the results, questioning Eddington's methods, and even accusing him of bias because he was so pro-Einstein. Some thought he might have seen what he wanted to see in those blurry eclipse photographs.
And even Campbell wasn't ready to give up.
Right.
He knew that more precise measurements were needed to truly settle the debate.
Yes.
So the scientific quest continued. What happened next in this epic saga of Einstein versus the universe?
Both Einstein and Campbell had to wait for another chance for another total solar eclipse that would provide the opportunity for a more definitive test. And that opportunity came in 1922 in a far-off land, Australia.
Australia. So the pursuit of scientific truth takes us to a whole new continent. Stay tuned as we unravel the final chapter in this thrilling tale of Einstein eclipses and the ultimate test of his revolutionary theory. Welcome back to our deep dive into the mind of Albert Einstein. It's been quite a journey so far, from his unconventional path to genius to those dramatic eclipse expeditions aimed at proving his revolutionary theory of general relativity.
And as we left off, the scientific world was buzzing with debate.
Right.
Eddington's 1919 eclipse measurements seemed to support Einstein, but skepticism lingered, and William Campbell wasn't convinced.
Right. He wanted more definitive proof.
Exactly, he wanted more data.
So the stage was set for a cosmic rematch.
Yeah.
Right. And this time the battleground was Australia.
Indeed. The 1922 total solar eclipse visible from Australia was seen as the ultimate test. And this time, Campbell was determined to leave no room for doubt. He spent years meticulously designing new equipment.
Wow.
A Cadillac of eclipse measuring instruments, as he called it.
A Cadillac. Wow, that sounds serious. So it was Einstein versus Campbell round two. Or were there other contenders in this scientific showdown?
Actually, it wasn't just a two-man race this time. The 1922 eclipse drew 7 expeditions to Australia, each hoping to capture those crucial images of starlight bending around the sun.
7 expeditions. It seems like the whole scientific world was holding its breath, waiting to see what the universe would reveal.
Oh.
So what were the results? Did Campbell finally get his vindication?
The Australian eclipse didn't disappoint. While some expeditions faced cloudy skies and technical difficulties, Campbell, with his state-of-the-art equipment, emerged victorious. He captured those clear, definitive photographs of starlight bending around the sun, and not just a few stars. His team measured the positions of 92 stars, and the results were undeniable. Einstein's predictions were spot on.
After years of doubt and debate, Einstein was finally vindicated. It's amazing to think that these eclipse expeditions, driven by scientific curiosity and determination, ultimately helped reshape our understanding of the universe.
It was a triumphant moment for Einstein, for Campbell, and for science itself. The Australian eclipse results solidified general relativity as one of the most profound and accurate theories in physics.
It's a testament to the power of perseverance, both for Einstein and for those who believed in his theory. But speaking of perseverance, remember how Einstein had promised his Nobel Prize money to his ex-wife Mileva as part of their divorce settlement?
Yes, quite a bold move considering the Nobel Prize was by no means guaranteed at that point. And the irony is when Einstein finally did win the Nobel Prize in 1921, it wasn't for his theory of general relativity.
Wait, what? If not for general relativity, then what did he win it for?
He won it for his work on the photoelectric effect, which laid the foundation for quantum mechanics, another groundbreaking area of physics.
So Einstein won the Nobel Prize for a different revolutionary discovery. And even though his personal life was far from conventional, his scientific legacy is undeniable. He became a global icon, a symbol of peace and intellectual brilliance in a world recovering from war.
He showed that even in the darkest of times, the human mind can achieve extraordinary things, and that's a legacy worth celebrating.
Absolutely. So as we wrap up our deep dive into the mind of Albert Einstein, what are the key takeaways for our listeners? What can we learn from his incredible journey?
I think there are many lessons here. Embrace curiosity, question assumptions, find inspiration in everyday life, and don't be afraid to challenge the status quo, even if it means going against established truths.
And remember, even geniuses face setbacks. It's the persistence, the willingness to keep exploring and learning that leads to breakthroughs.
And sometimes collaborating with others, even those who might be considered rivals, can push us further than we could ever go alone.
Exactly. Now, before we go, we have a physics challenge for you, inspired by Einstein's approach to problem solving.
Think back to those key concepts we discussed: visualization, challenging assumptions, finding inspiration in the everyday. Choose one and apply it to a problem you're facing right now.
What new perspectives can you discover? What innovative solutions can you unlock by thinking like Einstein?
Who knows? Maybe your next aha moment will be inspired by something as simple as a falling apple, a beam of light, or even a cup of coffee.
Thanks for joining us on this incredible journey into the mind of a true genius. Until next time, keep exploring, keep questioning, and keep thinking like Einstein.